I'm back. It's always the first day that I have internet problems too. Anyways, everyone's here now, so that is great. Welcome back to my friendly faces. This is Coastal Nav2, and I'm pretty sure everyone's here. So I've met all of you guys, at least virtually. We are going to go around a little bit and just introduce ourselves, what kind of boating experiences we've had, and yeah, that's pretty much it. Most of you know me, Captain Bree. I have went to the Maritime Academy and then worked in the commercial field, the Merchant Marines, as working my way up from third mate to captain on container ships, research vessels, oil rigs, and training vessels. I've done a lot of training with cadets and taught up in Seattle, and now I'm down in Long Beach teaching for OCC. So I really enjoy it and trying to help you guys out. So that's me. It's kind of weird to go around the room, so I'm gonna kind of call on you, and you could just introduce yourself to the class here. So let's start with Bill. You're on mute, Bill.
So I'm Bill Griffith, and I've done a lot of sailing taking classes at OCC for about the last 5 years. And I recently joined the Oasis Sail Club, and so sailing at least once a week with them. But I'd like to learn more, about navigation and most of the sailing I do is just day sailing. So I'd like to get more experience in navigation and those kind of things. So.
Do you guys do any plotting or anything at the Oasis Club when you sail with them?
I mean, it's like I said, it's mostly just day sailing.
Day sailing.
I think they do some, they use the electronic navigation and put in, waypoints for when they do races and stuff.
Okay, that's cool.
Yeah.
Cool. All right, well, thanks. Let's go to you, Milo. And you're on mute too.
Okay. Hi, my name is Milo Garcia, and I was taking classes at OCC, done some day sailing, but I'd like to get more into it, and I'd like to get to the point where I can charter boats and exotic places in the world and sail there.
I like it. That's a good goal. Take me with you. I'm ready to go on vacation. All right, cool. Well, welcome, Milo. And let's go with Greg.
My name's Greg Sergi. I live in Newport, and I sail 20, 30-foot sailboats. I've done a few different courses. I've been doing a couple classes at OCC, and hopefully we'll get back out in the water on the Harbor 20s in a few weeks if that class goes forward.
That's great. Sounds good. Yeah, OCC is opening up, so that's great news. All of my classes are still online, but on the water, in the boat stuff is happening again. So that's great. Cool. All right. Thanks, Greg. And let's go to Fred.
My name is Fred Yang. I live in Laguna Niguel. I start learning sailing last August. I intend to have a full speed learning curve and trying to aim to get my bareboat certificates last September. But of course, everything was stopped in March. So, I just started Basic Cruising 1 recently. And so it seems like Basic Cruising 2 is also ongoing. So it's going to be a lower pace than I initially intended, but I still enjoy it.
Good, good. I'm glad. We got the classes going again. So hopefully you'll get that bareboat certificate.
Yeah.
Cool. All right. And Mark. Are you with us, Mark?
Yeah, can you hear me, Bree?
Yes, I can.
Okay, great. So my name is Mark, and I had the pleasure to attend your first class, Coastal Navigation 1.
Yeah.
And since then, my wife and I purchased a 60-foot powerboat. And so I got some training on that to be able to handle this beast. And I'm anxious to kind of get to the next step and to learn more about coastal navigation. And I don't know if you're going to cover navigation by night. That was something I'd be interested in.
I guess not specifically navigation by night, but I can go over a little bit of that.
Okay.
Our last day we kind of go over a few different things. So yeah. That sounds like a good topic. Okay, cool. Well, thanks, Mark. Let's go to Tim.
Hi, Captain Bree. It's nice to see you again.
Yes.
And I see some familiar faces from the Nav2 course. My name is Tim Reister, and I am preparing for my inshore 3-day certification exam with Captain Ted Thornton in January, with the objective of owning and operating a boat with my wife in Europe as a part of our retirement plans.
Very
And
cool.
I'm just really enjoying learning from all of you. Bree, I thought you were an amazing instructor, and the way you ran the course, I was also able to learn from some of the participants as well. So I'm happy to be back for this course. Thank you.
Cool. Well, thank you, Tim. That's very nice. And let's go with Tiara.
Hi, I'm Tiara Megan, and I just finished with Tim Coastal Nav with Bree, and glad to be back to learn how to adjust for all the other things that are out there in the water. And and the goal is Patrick and I are empty nesting, and we, looking forward to new adventures. And I just, since I'm the backup on the boat, I think it's a good idea that I'm here.
Very much so. Very much so. Always good to have a little bit of knowledge of what's going on. So great. Cool.
Yeah.
All right. Well, thanks. And let's go to Michael.
Yes, hi everybody. My name is Michael Helms. I live here in Newport Beach. I had an opportunity to see a number of you as well from Nav1 class. Bree, nice to see you. I've been sailing probably over the past 30 years, owned some boats, and looking to probably just gain some further knowledge to go for some Coast Guard tests for my own personal use. So thank you, and I look forward to participating.
Cool. Thanks, Mark or Michael. And let's go with Patrick. I know you're with.
Hello, everybody. Survivor from Coastal Nav1. As Terry alluded to, we've been boating. We've been boating for about the last 12 years. We had a sailboat for 8 years, and we've had a powerboat for 4 years. And as she alluded to, we're empty nesting and just trying to build skills and, think about more than just staring at the electronic nav. And I hope this gets us where we. So it's good to see everybody again. And Mark, it's good to see you. I took a class with Mark, and then Tim, it's good to meet you. Tim and I were trading emails the other day, and ready to go when you guys are.
All right, cool. And we'll go to Brett.
I did. Oh, Brett, I'm sorry.
Yeah, Brett, sorry.
Sorry, I just had to take myself off mute. So hi, everybody. Haven't seen you in a week. So nice to see a lot of folks from Class 1, which I really enjoyed, and I second everyone's thoughts on that, Bree. So I grew up sailing with my dad here in the San Francisco Bay Area. He's a ring knocker. So now I'm in my 50s, been researching boats for a couple years, and I'm switching over to power boating next year. And the research part was really fun, and it's been great to have phone calls with my dad in his 70s and have him explain drift and dead reckoning to me. So it's been just a real family affair. That's fun. And by the way, Tim, my certifying instructor is also Ted, but just up here in the Bay Area. So I won't be joining you down in OCC. So anyway, I've really enjoyed the learning, Bree, and it's turns out that in your 50s, you still can go back to school and keep the learning experience, which I've really enjoyed.
That's cool. Thanks, Fred. And lastly, we'll go with Steven.
Hi, I'm Stephen Winston, and I was with everyone else in Coastal Nav1 from last week, and I actually am looking forward to learning how to sail. I've never done that. I started that adventure just during the pandemic, so I'm going to start taking first classes as soon as it is safe.
Very cool. Gotcha. Well, we have mostly sailors, I guess 1 or 2 power boaters here, but sounds like a good group. As far as logistics concerns, same as the other online classes I think most of you guys have taken with me. Everything will be posted on the Google Classroom. I didn't email you today, Tim. Shoot, I was gonna say I will email you, Tim. Yeah, we'll do the Zoom link. So this will be the same Zoom link for all 4 classes. It is only 4 this time. So this week we talk about kind of a bunch of vocab and set and drift. We practice with maneuvering boards. And then next week, we don't even have a PowerPoint. We kind of just go straight to the chart and do some chart practice with the things that we learned today. And then the third week is all about calculations. So I'm assuming you guys got mailed a packet, and you might have gotten something like this. It has printouts of the tide book. So you guys don't have to have the actual tide book. They're just kind of the Long Beach area ones that we're going to be using for this class. So that is our materials. We'll be using both of the same charts as we used in Coastal Nav 1. And then our last week, I go over kind of, it's a little description on electronic navigation, mainly the basics behind GPS and kind of what all those numbers and letters and code stuff means on your GPS. So we can figure out how to make it, translate it so we can put it on the chart and actually navigate. And I will touch mark on that navigating by night. So that's good thing to add into that PowerPoint. Other than that, any questions about class so far?
Yeah, Bree, 2 questions. I only received this package.
Yeah, me too.
Yeah, I didn't have the ones you
I was referring to.
Yeah.
There isn't a paper that looks kind of like that in there.
I didn't see one either.
Yeah, I saw there's a couple of pages that are.
What's it say on the top?
It says
Okay.
title differences and contents.
Oh, is that the
Los Angeles Outer Harbor.
Yeah, this is Los Angeles Outer Harbor, California, 2019.
Yes.
I've got that.
Okay.
Okay.
Yeah, I have that one.
Okay. So that's the one you need. I guess this one's just the pretty cover to say what book it's.
Yeah.
All right. Second question. You is this sheet is what you're referring to radar plotting sheet?
So I think that one is considered a maneuvering board.
Yeah.
But we can use it as a radar plotting sheet. So you can definitely use that one.
All right. Okay.
And we will go into that.
Just FYI, from Amazon for $16, you can get this radar sheet. Just if you order it, that's what you get. So it's much bigger.
And honestly, when I'm doing the in-person ones and I see you, I have the big packet thing like Brett there, and I just rip off 2 or 3 for each of you guys. And that's all you really need for this. But let me share this guy. On the Google Classroom, I do have extra assignments. So we have our regular assignment 1, 2, 3, and 4, kind of same style that you've seen with me. And then I have extra problems from different places, and they're mainly U.S. Coast Guard license practice problems. So I think this has another 25 problems that you guys can practice with, which I definitely recommend, because 20 problems, another 20 problems, just so you can really master the skill. And if you have extra plotting sheets, then you can totally do the extra problems. So I do have extra problems. For the answers, it's a little bit different than Coastal Nav 1. For week 1, you have the assignment and the answers in the same section. I didn't really like how it was hard to find all of the answers the way Coastal Nav 1 was set up, and I couldn't figure out how to rearrange it. So I did it a little differently this time. On your reference material, there's a lot of stuff here. You have the radar plotting sheet, maneuvering board. You can just print those out if you didn't get one. The reading. I don't know if you guys got reading in your packets.
Yes.
Yeah, I got it.
You get the reading. Okay. So we don't really use the Coastal Nav 2 book. As you can tell from Coastal Nav 1, I don't really follow along with the book, but this is another great read for what we're going to be talking about. So you have that guy. The deviation table we'll be using, it's the same deviation table from Coastal Nav 1. My step-by-step guide to the tide problems, and that's calculating tide, which we'll get into week 3. The tide table handouts, that's the 2019 ones that I'm pretty sure everyone will have. And then links to the actual like 2020 or 2021 books, if you're interested in doing current ones, which I'm sure you are. And then a GPS article. So check out the reference material there. And that's pretty much it for that. I think if we have any other questions, we'll dive right in. All right, let's do it. Why is it not sharing? Hold on. All right, so this class is mainly focused on set and drift and the movement of water. So we know that most of the time when we are steering a certain course, we're not actually going that course. So we're going to learn all about that. So to start off, and again, throw out some answers here. Why would our actual position differ from our DR position?
Tide.
Tide. Not necessarily tide, but we'll get into that answer. What else?
Wind and current.
Wind, current.
In the reading that it said also that if something about 18 feet, if the water is less than 18 feet deep, that.
Yes, depending on your hole shape, your speed will definitely change, which will essentially then change your DR position depending on that underkeel clearance. There's kind of what we call suction, and that happens a lot on big boats, kind of in a river. You have bank cushion and bank suction with that water dynamics kind of thing. But that same kind of thing happens, and it's called squat. but it does happen on small boats with certain hull shapes as well. So one we didn't talk about was our DR position was wrong. We had math errors, and it was just flat out, maybe it was plotted wrong for some reason. Our current, that's that horizontal movement of water. Gonna push us one way or another. The boat's weight. So as you are transiting, maybe you have a long transit going from Newport to Hawaii or something, your weight will get lighter and lighter with the fuel consumption, or if you're taking on more water to ballast, the boat's weight can affect your speed. And so if you think you're doing a certain speed over a long period of time, if you're only DRing, that speed correction can be off. What else do we have? And then what Bill was talking about, the water depth. That shallower water can change our speed. Shallower, less than 18 feet. We have displacement versus the planing boats. And essentially you'd speed up in shallower water. So let me make sure. Here.
Bree,
So that, yes?
when they talk about a big boat versus a small boat, what constitutes a small boat? How long would you consider a small boat? Like 35 feet, 60?
I don't have a good answer for that. Does anybody else have a better answer for a small boat versus big boat?
Well, wouldn't it be more about the weight than the length?
I can't answer for the small boat, but I can answer for the physics. This is the exact same thing that happens in planes. It's called ground effect in planes. What happens is that as you look at the way that a fluid, and air is a fluid just as water is a fluid, reacts to a movement through the fluid, it creates vortexes underneath the plane as well as the keel of the boat. Vortexes hit another object such as a plane like a ground or like the seabed. What's going to happen is that the vortex will be interrupted and no longer come up to the upper side of that vortex where it's hitting the plane or the boat as it does normally. That allows the aircraft or the boat in this case to move better through the water or through the air, through any kind of liquid. So fluid dynamics tells us that if you eliminate a vortex, you will have less forces impinging your movement forward. That's why you're going to have better results with things like reducing the amount of a keel you have in the water. You can move faster, but you don't have the ability to maneuver as easily. Same thing with the plane. The closer you are to the ground, the better the plane actually flies.
Ah,
Oh, interesting.
thank you.
I guess to another short answer to your question, to get if you are operating something over 100 tons, then you need a Coast Guard license.
Okay.
So I want to say kind of 100 tons and smaller would be a smaller boat.
Okay.
Another thing they like to say is between ships and boats, you can put a boat on a ship, but you can't put a ship on a boat.
Okay.
Does that make sense?
Yes,
I don't know.
it does.
Okay.
Okay, thank you.
Yeah. Okay. So our actual position will most likely always differ from our DR position, because our DR position is just those three things: a known position, and then we have our course and speed. So we create a vector. It's just purely calculated with course and speed to give us a DR position, dead reckoning position. So our actual position will most likely be different. And then our last one was wind, which we call leeway. Okay, so now we're going to go in to vocab. So this is kind of a lot of little vocab words here. But our first vocab word is current. The current is the horizontal movement of water, where tide is the vertical movement of water. Current is the horizontal movement of water. Those are two different things. So when you say the tide is pushing you, that would be a false statement. It's the current that is pushing you horizontally. The tide is lifting you up or getting you closer to the sea floor. So the tide is a vertical movement where the current is a horizontal movement. Within current, we have two descriptors. We have set, which gives us the direction of the current. And with current, the direction is always towards which the current flows. So if you have a northerly current, it is pushing you to the north. So if you're just sitting in a little life ring or floating, that current is going to push you to the north. Where wind, if we say there's a northerly wind, that wind is coming from the north and pushing us south. So wind and current are opposite when we're looking at direction and how it's affecting our boat. So we want to keep that in mind when we are thinking about currents, and we have a direction of the current and which way it's pushing us towards. My little memory aid for that is current has a T, so it's to, wind is from, I don't know. Also for remembering set, it's which way does the sun set? The sun, sets in the west, rises in the east. So set is a direction. It has to do with direction. Where drift, so we have set and drift, which create a current. Drift is the velocity of current. That's how fast that current's moving. So that current is moving, but how fast is it moving? That's the drift part. So how fast are you drifting down the beach? I don't know. I don't have a really good memory aid for that one. But drift is a velocity. So drift is in knots and set is in degrees. It's a direction. Does that make sense?
Would it be correct to say that the tide creates a current, even though you say it's just the vertical movement of the water?
I guess you can go back and forth with that. The current creates a tide, the tide creates a current. They are, linked in that way because it's a movement of water.
Yeah.
But when we measure them, with current, we measure the direction and the velocity, and with tide, we measure the change of height.
Yeah.
So they are, related. As all the water moves out, your tide's going to go down, right? And as all the water moves in, your tide's going to come up.
But they're two different things.
But they're two different things, yes.
Okay.
And when we calculate them, they're two different books. We have a tide book and a current book. So there are two different predictions when you're looking at NOAA or whatever it is.
So the tide, you're just looking at that for clearance, for getting under bridges and.
Exactly.
And for current, it's just which way you're being pushed or, or pulled, I guess.
Yes. Yeah. So we have set and drift, and then we have two words that go along with the set in the direction, and that is ebb and flood. So ebb is when, ebb is when the current is moving away from shore or downriver. It's going out of the harbor. That is the ebb. The flood is when the water comes flooding into the harbor. Let's do that. So the flood is coming in, the ebb is going out. So it can be, current is mobbing, that's a typo. Sorry. Current is moving towards the shore or upriver is your flood. And then our slack is when there's no horizontal movement of water. It's, you know, it starts flooding, it stops, and then it starts ebbing. So there's that point where there is no horizontal, or as close to no horizontal as possible. That is called slack. So as close to zero as possible. And that's what happens when it changes from an ebb to a flood, and then from a flood to an ebb. So we have slack on either side of each kind of cycle, if you will. So I guess to continue with that, so I guess our water starts at slack, and then as it goes in, that would be flooding. All of our water is coming into the harbor, and it kind of peaks out as a very, very fast, and then it starts getting slower and slower, but it's still coming into the harbor, but it's slower until it gets to zero. And then it starts going back out slowly, and then it gets fast, and then it gets slow again until it goes to zero, and then it goes back the other way. So you kind of, and we'll look at an actual picture, so you're not trying to picture what I'm saying. Let's do that. Let's go to a picture. Okay, this is a little bit blurry, but we have our flooding into the harbor, our ebb coming out of the harbor. And then we also have, which we're not going to go too much into, is you can have rotary tides depending on basically kind of the seafloor. Okay, let me skip through this. There we go. So here is a graph of the current. So this is, there we go. Here's our flood, here's our ebb. So we are ebbing, meaning going out of the harbor, and then it gets to zero and it starts flooding, coming into the harbor. It peaks at a certain speed, and then it gets less and less until it gets to zero, and then it starts going the other way until it peaks and then gets less and less, still going, still ebbing. So this whole section here is flooding, or excuse me, ebbing, but it does have that peak speed, and then goes back to zero. We got a little flood, ebb, etc. So yeah, just to kind of visualize what I was talking about there.
And this is the current generated by the tide as it comes. Is that?
So the tide, so Bill was kind of saying that the tide and the current are definitely related to each other, right?
Right.
So when the tide comes, or when the current is moving all the water in, our tide comes up.
Oh, okay, I understand.
And when the water goes out, our tide goes down. But if you look at tide and current on the same day, it might not match up exactly. Like it's pretty close. Like you can, if you only have tide tables, you can just guess that, hey, our maximum push will be some point in between our time. And I will show you that. Let's go back to that.
Ray, are you going to post this PowerPoint on the classrooms?
Yes, it is posted on the classroom.
Okay, thank you.
And the recording of this video will be posted as well.
Okay.
Okay, so tide. So that was current. Now we're switching our gears to tide. With tide, it is the vertical movement of water. So vertical, the tide is coming up and going down. We don't have the out and in. Tide is going up and down. And we always apply this tide to our charted depth. So the tide is not the depth of water. So if you have a 5-foot tide, it doesn't mean that you have 5 foot of water. You apply that tide to the soundings on the chart, whatever the charted depth is. So for all of Newport, we have all these different depths, right? Throughout the harbor. But if all of Newport has a 2-foot tide, you're just applying that 2 feet, you're adding that 2 feet to all of those numbers. So you'll still see that, you know, the contour of the sea floor, the water level is just higher. And that's what the tide is. So you can have a negative tide. So negative tide doesn't mean you're, you know, seeing the rocks or anything. It just means that it's lower than the charted depth. So that's your tide. You always apply it to the charted depth.
So isn't the charted depth, I know it's reviewed, but isn't it something about the mean low tide?
Yes, yes. So the chart datum is mean lower low water.
Yeah.
So it you know, averages on the side of safety. But yes, it's mean lower low water. But the tide calculations are just applied to that chart number. Okay, the range of tide. So the range of tide is the difference between 2 consecutive tides. So if we have a really high and a really low, that change is a lot bigger. So I'm going to make another statement here. The bigger the range, the faster the current. Right? As if we have a very small range, we're not going to have much current because the water isn't changing that much in the cycle.
Is the duration always fixed between the high and the low? I mean, is it the same amount of time?
So it is not.
Okay.
Southern California, it is not. Most of the places around the other world, it is.
Oh.
Southern California is not completely the same like that, but I do have a chart on that as well. So the range of tide, we use range a lot, right? Range was our distance when we were plotting a bearing and a range, and then we had those visual ranges that we were trying to line up coming into a harbor, and now we have range of tide. It's this word that we just like keep on using, and I understand it can be very confusing. But range of tide, this is going to be one of our things when we're calculating tide, of how to find it. So it's the difference between 2 consecutives. So it's not your average, or it's not the averages between the 2 lows, or the differences between 2 lows or 2 highs. It's the consecutive between the water was here and then the range was it dropped to here, or it was down here and it rose to this height. What was the actual range of that period of time? Consecutive high and low tides. So that's your range. Then we have the stand. So a stand is kind of like slack. It's that point where the water gets higher, 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 and then it stalls out, and then it gets lower, lower, lower. Then it stalls out, and it gets higher, higher, higher. So that stand is when there is no movement, that we have no change in the height of water. That's our stand.
What's the difference between stand and slack?
So slack has to do with current, which would be the horizontal movement of water.
Okay.
Where stand is going to be that vertical movement of water. So very, very similar, right? But we're kind of separating those 2 things between tide and current.
Okay.
Is it often that you'll have stand and no slack, or vice versa?
So I would say a stand always happens, where a true slack might not. Like a slack might be, 0.1 or 0.2. There's a table in the back of the current book that has the slack ranging from 0 to 0.6 knots. So that slack is as near as possible as it gets to 0, but sometimes it doesn't always get to 0. If that makes sense. Where your stand definitely will always stop rising and then come down. There'll always be a stand.
Okay.
Okay. And then, oops. Has anyone heard of those king tides or spring or neap tides? And you're like, oh, that sounds like an exotic tide. Like what are they talking about there? So tide, mostly, is has a lot to do with the moon and where the moon is positioned. So I have a bigger picture of this too. Let's go there. Hold on. Here it is. Okay, so our spring tide is when our moon is in line with the sun, right? So the moon travels around the earth about a month, right? We have a full moon every month, give or take, lunar cycle. So when the moon is in line with the sun and the earth, whether it's on the backside or in between the sun and the earth, that is when we have more gravitational pull with the moon, and we'll get those higher highs and lower lows. So we get more extreme ranges, if you will. Our ranges will be more because it's higher highs and lower lows. Where when you have a neap tide, that is when the moon is at the quadrants. So when we have a half, kind of that D, right? That perfect D, that half moon. That is when that gravitational pull is least. So you'll have kind of our tides are range is less. So we have higher lows and lower highs. Let's go back to this one where it's written. Here we go. So increased range and speed, that's for current. When the moon is new. With a neap tide, it's decreased range and speed when you're talking about current, when the moon is at quadrant.
Bree, on the spring tide, I assume when moon in that new moon position, the tide will be the highest, right? Because
new or full moon, yes.
But I feel that the when it's in the new moon position, because it is close, it's on the same line with the sun, so all the gravity is pulling that direction. But when you're in the full moon, actually the sun is pulling that one direction, and the moon is pulling on another direction. The tide should be smaller than the new moon position. Is that true or not?
I want to say because the earth is moving, that the tides kind of like squish out. I guess I don't have a good answer for that. I understand what you're saying.
I could give a physics answer again, but
go for it.
Basically what happens, because the earth is round and because it's spinning, you have the rotation of the earth that's causing an elongated disk of the water to begin with, without any other outside forces. If you add in the force of gravity coming from the sun and the moon, you do have extra forces on both sides of that disk. But because it's spinning already, you have to deal with the fact that it is a gyroscope. So anything that you do to one side of it will actually reciprocate and do to the other side as well at the same time. You can't have the elongated disk move further out to the moon than it would to the sun, or vice versa.
Because it kind of squishes. It has to happen on both sides.
Yes, it's due to the gyroscopic effect.
Okay.
I don't know.
I want to say thank you, because that explains, like, during the day you get 2 high tides and 2 low tides.
Yes.
So like the water bulges on both sides and it gets shallower on both sides.
Yep.
So that explains it, what you just said. Thank you. I've always wondered about that. I'm off now.
All right, cool. Okay. So this is that chart that's in chart number 1. And we are talking, and I just want to emphasize here, we have the chart datum. So this is the height of the water according to the chart. And then if this is our actual, we have the charted depth. According to the chart, this is the charted depth. And then we have the tide to make our actual water. So we add our charted depth and our tide to get actual water levels. Okay, that's what I wanted to show there. We went over this one. Okay, so here we have in, I guess, everywhere except Southern California, we have what they call a semi-diurnal tide. And that is 2 highs and 2 lows throughout the day. And if we have 2 highs and 2 lows in a 24-hour period, every 6 hours, we're going to have a high. And then 6 hours later, we're going to have a low. 6 hours later, we're going to have a high. 6 hours later, we're going to have a low. It's very cyclical. Cyclical. Word. That's predictable, and we have the semi-diurnal tide. So that is most prominent around the world. Here in Southern California, we have a mixed tide. And that is where our high and our low, and then our high and our low are different. So let's look at a picture of this. Here is a great example of our tide cycles for high and low tides in Long Beach, Terminal Island. We have a low, and then we have a high, and then it goes low, but it's just a little one, and then it goes back to high, and then back to low. So it's this mixed, it's not completely every 6 hours you have the same predictable where the water is going to be. In Southern California, we have mixed tides. So yay for us. Woo! Okay. When we are looking at the, this is tide, right? This is in feet. We don't have direction or speed. This is tide. We have that stand of tide when it gets higher, 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 and then it gets lower, lower, lower to stand. That's our 0 movement. Where we have the biggest slope, if you will, that is where we're going to have the fastest current. So we're separating our tide and our currents. But if we only have, you know, those little pocket tide books that a lot of places give out for free, if we were in person, you'd get one from OCC. It only has the tide tables. It doesn't have the current tables, but you can use those tide tables to try to predict when we're going to have a, you know, a fast current. So that peak of the current, if we look at, let's say, a current table, when we have this peak of how fast that current is moving, that is going to be when we're looking at our tide table here, when we have the fast moving current, the rapid change, and then the current gets slower and slower until we stand. So when you look at a current chart, this one's current, we have, let's see, we have no current, so no movement of water, and then all the water moves out. It's ebbing, ebbing, ebbing. It's moving out, it's moving out, it's moving out, and then it stops. And right when they're at zero, that's when you're going to have your high or low water. So if this is an ebb, they call it minimum after or minimum before flood, minimum before ebb. So right here would be our minimum before the flood. That would basically mean a very low tide. And then it starts to flood and we get a higher and higher and higher tide.
So is current, the relationship between the two, is it always an integral? Is it always just calculus using integration?
I don't know.
Hmm.
I don't know what integration, what.
Or are they linked together, I think is what he's saying. If the tide's changing, I mean, the current's changing.
Yeah,
You
so
know?
take the integration of the slope. The slope is going to be greatest, as you're saying, the fast current rate there.
Mhm.
That's an integration. So at
Okay.
that point there, you're saying that would be the greatest in the other
Yes.
part.
That would be your greatest on the current diagram, your
Right.
max speed.
So my question was, do they always enjoy that kind of relationship?
Yes,
Okay.
I would say yes. Yeah. Does anyone have a website or something that they use that they can share with the class to check tides or current? Because all sorts of websites give you different charts, if you will.
I've
What
been
do you-
using this tide log. It's called Tide Log. And because I surf, I use it to check when I want to go surf. And it gives you the chart, but it also tells you the ebb and the rate of the ebbs and the floods.
So it has both the tide and the current overlaid.
Yeah.
That's pretty cool.
Yeah, it's that's why I was asking. I'm like, well, it's all here, but you're explaining it in more detail.
Okay.
But I've been using it forever. And in the back, and I'm hoping you'll probably go, there's like a tide correction based on the location. You'll go over that?
That's week 3.
Okay. Because I kind of get how it works, but I could use more explanation.
Yeah.
Hey, a minor sidebar. A really exciting day at the Megan house is when the new tide log shows up.
I'm a total nerd. Okay.
I love it. And they come out yearly, I'm assuming.
Yeah, you get it every year. It's a subscription. And it even gives you every week it gives you what's going on in the skies too, like transit of Mercury and what's,
cool.
There's a comet coming through. So yeah, we
Very
keep
cool.
one on the boat and we keep one at home.
I like it. Anybody else have a website that they like to check when going out? Tide or current website? Okay, I don't have one to share. On commercial ships, we have a software program that has the yearly tide tables kind of printed, and we could print any kind of graph that we want and we kind of customize it.
Wow.
But I'm sure that one's, costs money, and there's got to be tons of free ones out there. I'm just saying. You could just Google Long Beach tides and there'll be a ton that come up, or Newport tides or whatever. So yeah, scope them out, see if you like anything. All right. Let's see. Oh, these are more different charts. So it kind of depends on how you like to look at it. So how do we determine what the current is? So we're moving into current again. For tide, we're really concerned about tide when we're, making an approach to a harbor, and there might be we have to go over the sandbar, or you have to make it under a bridge or some power lines, or you're concerned with the height of the water. that's when you want to determine the tide. But you want to determine the current a lot, I would say a lot more, because you'll be navigating in and out, and that current is going to be pushing you. Even if you have a relatively shallow draft boat, you're not necessarily concerned with running aground over the sandbar or not making it under the bridge or not. So we're going to focus on current now. So how do we determine what the current is? Any guesses? There's two ways.
Probably direction.
The direction and the speed.
Correct.
Well, you said there's a chart? or a
Yes.
book?
Yes. Oops. I went the wrong way. First one, nav pubs. We use our nav pubs to predict, or websites or apps, there's all sorts, to predict what the current is. And then we can apply that to the future. So if we know we're going to be leaving Newport and headed to Avalon, we can say, oh, on, October 30th, what's the current going to be? Let's predict it into the future. That's where we use our nav pubs. What's another way?
It sounds like integration will work from your tide chart.
So that would be nav pubs again. The second one that I've been trying to find is we could find what the past current was by comparing our DR position, our purely calculated position, to our actual position. And the difference between those two is kind of our group set and drift. So I like to call, when we talk about the difference between our actual position and our DR position, kind of set and drift, because that kind of lumps in poor steering, wind, leeway, current, swell, kind of all of these things can be combined into that. But we can use that if from 8 o'clock to 8:30, the current pushed us in this direction. I can say, hey, probably from 8:30 to 9, the current's still going to be somewhat the same, maybe a little less, maybe a little bit different, but that can help us be more accurate on our next DR, or where the current is moving us, right? So, so when comparing our just purely calculated position to our actual position, whether we got it from a GPS, whether we got it from bearings, from radar, from whatever it is, we can compare those two and get our set and drift. The set was the direction, the drift was the speed. And how we do that is, this is, I guess, my term here, is we create a vector triangle. And we are going to dive in here to creating that vector triangle. Before we dive in, let's take a little break. I'm trying to be more aware of breaks. I know I'm kind of get caught talking to myself all the time, so I'm trying to be more aware of this. Let's take a 10-minute break here, if that's okay. Any questions so far before we go on break? You guys doing okay?
Question. So if those books give predictions of the current, and the current's affected by the swells, and the swells are affected by the weather, I mean, the weather isn't that predictable. So, I mean, it seems like that's a big variable.
So there are kind of these predictable currents, and then we have wind-driven currents and rotary currents, and there's a little chart in the back that's called combined currents, and that's kind of what your actual, I'm trying to find the picture, what is actually happening is that you have this wind-driven current, this predicted current, maybe you have a little bit of a rotary current, you have all of these kind of things combining. But when we talk about that vector triangle, when we compare our DR to our set and drift, we're kind of combining everything. We're combining leeway. We're combining everything into one kind of effect that then we're going to predict from there. So again, this is the art of navigation, right? We are trying to figure out the best possible location of where we are, but we're using as much information as possible. But again, it might not be exactly. It always feels great when you're like, I think I'm going to be here. And then you plot your position. You're like, dang, I was right where I thought I was going to be. But there's a lot of different things that can come into play. There's my dog. All right, well, let's take a little 10-minute break here. How's everyone doing? We make it back? Wait a little bit here.
Bree?
Yeah.
Do you have like extra running fix exercises by any chance?
I can try to look some up.
I know it was last class, but I just feel like that one was the one I really needed the most practice with.
Okay.
I would, Bree, I would definitely second that. That would be very helpful.
I think a lot of you guys will. I will try to create some or mostly look some up and then or create some and yeah, get some running fix problems.
Thank you.
Yeah.
Simpler the better too, Bree. Be good.
What was that?
Simpler the better.
Simpler the better.
Yeah.
Got it.
Yeah, I had a lot of running unfixes, so definitely would be great to practice.
And answers too, because sometimes I had to work backwards trying to figure this thing out. So,
okay.
Hey, Bree, one question with regards to tides and currents. Are you going to get into anything where you talk about how the current can accelerate based on the topography of the land or the sea bottom coming into certain areas?
Not so much.
Okay.
At the end of this PowerPoint, we go into what they call tidal currents versus ocean currents, which basically has to do with that. I would say topography of the sea floors are tidal currents versus the ocean currents.
Because I've just seen that sailing around, like around New England, Maine, coming down off of Massachusetts through like Long Island Sound, that part of the coast, because of the different topography. I mean, you can come through some inlets that have got some pretty swift currents.
Yes. I guess we don't go into like the why behind it, as more of just predicting what it is. And you'll get a bigger tide change, you know, like the mouth of the Golden Gate Bridge or the Straits of Juan de Fuca versus throughout the whole bay, the Puget Sound or the San Francisco Bay or something. But we don't really kind of go into the topography behind it.
Okay.
So, yeah. Okay, let's get back.
And here I was looking forward to some Navier-Stokes equations.
You could cover that one, Stephen.
No thanks.
I try to make things real simple. I'm no scientist. Just a little navigator over here. All right. Let's get into our triangle, the vector triangle. So we have 3 sides to our triangle. So these are 3 different and measurable things. Our first one is going to be the current, and that has 2 components. It has a direction and a speed. Now, when we draw this triangle, we convert that speed to distance using our 60D street. So we can create a length and a direction. So we have a starting point and an end point to that little leg of our triangle. We have a set and a drift. That's a direction and a speed. And that's the current. So we either get that current from the past, or we've predicted it using a tide current tables, apps, whatever we've had. Our next line is going to be what the boat is doing. So the boat is, we're going to imagine it on autopilot, where it is steering a course. And that is what we are steering. That's where the boat is pointing. And it is always pointing for this time, however long our triangle is going to be, an hour, half hour, whatever it is. We have our boat's course and our boat's speed. A lot of times sailing, that boat speed can be very hard to kind of nail down and see what it is. If you have a Doppler, you can use that speed through the water, a Doppler speed log, or you can do that calculated speed by engine. For power boats and mainly for commercial boats, we typically have a little chart that says, you know, if you are dead slow ahead, you'll be going 5 knots. If you are slow ahead, you'll be going 8 knots. If you are ahead, 10 knots. If you're full ahead, 15. Full sea speed, 20, or whatever it is. That you have either that dead slow kind of thing, or you have that kind of language, or you have RPMs. That if you are at, and RPMs are totally different on different vessels. So when I say RPMs on the ship that I was on, it was completely different than the RPMs that my husband uses on his ship versus the RPMs that you guys might use on your power boat. So maybe, you know, you have 100 RPMs, that's 1 knot. 200 RPMs, that's 3 knots. So if you can adjust your RPM gauge, you can predict what speed you're going to be doing. So that's the speed by engine. If I have set full throttle, max I can get full throttle is going to be 8 knots. So if I'm going, my engine is pushing me at 8 knots and my autopilot is steering me, that current can either be making me go faster or making me go slower, right? It's going to have one effect over the other. So the boat vector or little line of the triangle is going to be what the boat is steering and what the boat's speed is. I understand the sailing speed can be difficult, but we're just going to practice this concept, if you will. And then we have the made good line. So this is what actually happened over the ground or over the bottom. Speed made good, speed or course made good, speed made good, or over ground. So this is what is actually happening. So if we know the current is pushing us and this is what we are steering, that, you know, final leg of the triangle is going to be what actually happened over ground. We're combining these vectors. So I like to make a note here that this is either made in the past or to make. So if I want to make a certain course, if I am headed into the channel and I want to make this course, and I know the current is going to be pushing me to the south, that I need to adjust my boat's course towards the north. So to adjust for that. So it's either made good in the past or to make good, if you will. And that's course and speed. So each leg of the triangle, oh, wait, I have a little picture here. So where your actual wake goes, that's going to be over your made good line, right? So my boat is pointing in the direction of my boat's line, and the current is pushing me this way, but my boat actually travels over that made good line. Okay. So even if I have a position I fixed my position, and then I plotted my course and speed. I plotted a track line. I might not be going on that track line. My made good is probably not over that track line, right? Because we are going to be affected by some sort of set and drift.
Seems to me like that arrow's pointed the wrong direction, but is that just a convention that you point the arrow towards where the direction of the set rather than no?
What are you talking about? The set and drift arrow?
Yeah, it seems like that the arrow is pointing one way, but it seems like the effect is going the other way.
So this is saying that the current here is pushing us to the northeast.
Oh, okay.
Right? It's pushing us towards the northeast. And so if I want to be making good north, then I need to steer to the left if it's going to be pushing me this way. If I just steered straight, I would be going that direction because the current would be pushing me. We have some examples here. Let me get some examples and maybe it'll make a little more sense for you. Okay, so those are our three basic lines. We have the current line, the boat line, and the made good line. Each one of those lines has a direction and a speed. And we're going to convert that speed to distance so we can plot a little triangle. I like to make a little graph, and I will make this graph over and over and over again. Just so I know all three of my legs, and each leg has two values, if you will, that course and the direction, or the course is the direction and then the speed. So when we use a plotting sheet or maneuvering board or a universal plotting sheet, whatever it is that you're using, these two are going to start from the middle, and it will be a lot easier if you start from the middle with the made good line and the current line. Those are what's, the current is pushing you to the north, kind of over ground. I like to think about that the current is pushing you over ground. It's northerly current or northeasterly current, whatever it is. That starts from the center. The made good starts from the center. And then the boat line does not start from the center. So if you're making a triangle, one of your lines can't start from the center, and that's the boat line. You can do this on, a chart, on graph paper, on all sorts of different things. So my little memory aid here that the made good and the current start from the center might not be used all the time, but this is just an exercise in learning the triangle and how our boat's heading, our current, and what course made good ends up to be are affected by one another, and how we can create a triangle. So if you're doing this on a chart, you probably won't have a center, right? We're just on a chart, but we're going to practice how this triangle works by using a maneuvering board, and that's when we have our center point. So actually I'm gonna go to my whiteboard. So we have different things that we could use. You could essentially use graph paper, but I have requested that you guys get radar transfer plotting sheets. This is what I found is easiest to work with for beginners when we're learning this triangle concept. Hopefully you have that. If you are testing with the Coast Guard, you can have access to maneuvering boards. These are essentially the same thing. They have different scales on either side. They just have I don't know, more dots, more clutter. So I like using the simpler one for learning this, but if you are testing at the Coast Guard, these are available to you. So if you want to be familiar with them, you can. And then for those of you who took my celestial class, you might
Can anyone see Bree?
No.
Yeah, stop for me.
Oh, yeah.
Yes.
Yeah, it looks like Bree is down.
She locked up.
Yeah.
Looks like she's logging back in.
She went overboard.
Okay.
Yeah, she's not listed as a participant right now, so we gotta, I think, wait till she comes back online.
Oh.
Sorry, guys. I don't know what happened there. I got cut off. We're back. Okay. Literally on the first day of class, my internet is wonky. Okay.
Put me through celestial navigation.
What was that?
The last word you said was in your celestial navigation course.
Oh, okay. Thank you. We'll go back. Okay, so that I was talking about universal plotting sheets. Okay, so you can use any of these. Hopefully you have a radar transfer plotting sheet. That's what I'm going to do my examples on when we follow along for this class. On this radar transfer sheet, we have the middle, that's the little X. So that's going to be our center. So when I say made good and current start at the center, this is where they start, right here at the center. And then on the outsides here, we have our direction. So 0, true north. We have east, south, west, just a regular compass. 360 degrees around. And then on the side here, there we go, we have our distance scales. So these rings can be different distances, but once we decide on a distance, that's the distance we're going to use. So let's just say we're going to use the 12-mile scale. I like to cross these ones out. We're not using those ones. We're always going to use the 12-mile scale. So that says, okay, this is 2 miles, 4, 6, 8, 10, 12. So this ring gives me 2 miles away from the center, 4, et cetera, et cetera. So, and that's kind of the bold number here, if you will. So when we measure distances, we can use this scale to plot. Ever we have a line, so let's say here's a line, 0, 4, 0, it's starting from the center. If I have a line, I'm just going to draw a random line on our plotting sheet. To measure the angle of this line, let's say, okay, we have a starting point here and a starting point here. To measure the degree and the distance of this line, I need, instead of just going out to the edge, that's a very common mistake in saying, okay, this is my degree. I have to bring that down to the center, kind of like back down to that compass rose, in order to measure the bearing of that line. So I would get my line, bring it down to the center, and say this direction or this course or bearing, whatever it is going to be 082. So it always, when you're measuring a line, you're measuring it from the center if you're using these, this radial here. I hope that makes sense. For distance, you use a little distance scale. Using our distance scale just to measure what a distance would be. Okay. That was a quick little intro to a plotting sheet, but I wanted to clarify when I said the center. What the heck? Why is this weird? Let me just do it. Okay. Can everyone see the PowerPoint now?
Yes.
Okay. So our made good and our current are going to be measured from the center of our plotting sheet. Our boat is not going to start at the center of the plotting sheet. Out of these 6 values, right, we have 2 for each line, 4 will be given to us and 2 will be missing. They might be 2 different values on 2 different lines, but we can still figure out what the answer is. So we have, out of the 6, we have 4 values, could be a mix of what 4 values we have. And then we want to find out what the 2 are. So we want to complete the triangle. And we are going to do some examples of this. So I always like to make this little chart. That way I could kind of figure out what my missing pieces are and what I can start with, because my starting point is always the center. And then I build from there with these values in the chart here. Okay, maneuvering boards. I guess I kind of went over this a little bit. You want to use the largest scale possible. So if you are traveling at, you know, more of the 4 or 5 knots and you're going pretty slow, maybe the 12 mile or the 24 mile, you're going to have a triangle that's very small and hard to work with. So you want to make your triangle as big as possible, meaning use the largest scale possible. The directions are always established from the center, like I said on there. So you will need at some point to parallel your line back down to the center to find most likely your course to steer, because the boat, right, the boat's course is the one that's not on the center. The made good and the current are on the center, but your boat's course, the course to steer or course that you're steering, is going to be the paralleled course that we have to parallel. So we can use, like I said, all of those little things. Okay. Now my quick tip here is to set all of our values to 1 hour. So if I have a course and a speed for all of these different values, I want to set it on the 1 hour so that I can quickly do that speed to distance ratio, right? Because right here I have 10 knots. So in 1 hour, I'm going to go 10 nautical miles. So that is quick math, and we want to be as quick as we can. I will say on our homework, I did give you a question that was on the half hour, not every hour. So we will have to do a 60D street at some point. But most of the time, we always like to create our triangle on the hour just so our math is easy. Makes it easier on us. So let's look at this question right here. So this is kind of the triangle that we're working with. If you have a maneuvering board, you can try plotting it. So this has all of the values, and this is just the triangle itself. So our course made good is due north, right? So starting from the center, down here is going to be the center. Our course made good is going to be due north. Our speed made good is 10 knots. So that distance of this leg is 10 miles. Then I have the boat over here, which does not start from the center, right? My current starts from the center. So I can see what my current is, 045, pushing me 045 at 2 knots. I would say this probably isn't exactly to scale, but let's go with it. So just by looking at these lines, I can see that what my boat is doing is going to be slower than what my made good is. So if I knew my made good was 10 knots and I have this current pushing me along, I can guess that that's probably going to be a lot slower. Not a lot slower, but a little bit slower. So it's always good to do that. Does this make sense check? Let's look at the big picture here and say, yes, if the current is pushing me in this direction, I'm going to go a lot slower. I'm going to go a lot faster than what my actual boat speed is, or my course made good, or vice versa. So we always want to like look at the picture and be like, okay, I have all these values in my little chart and I have my triangle, but does this make sense? And me with my little toys over here, I like to put my little boats out and picture it. So we'll see that. Okay, so let's do an example together. I'm kind of going to go back and forth here between the example PowerPoint and my paper, if you will. So let's grab a new piece of paper. And I am, let's get back to it. We have a current will set us. So we've looked up this current via an app using the nav pubs, something that is going to set us 200 degrees true at 2 knots. So that is towards, the current is pushing us that's too many twos, towards 200. The navigator wishes to make good. So I want to make good a course of 300 at 10 knots. I have a, ETA to make. I want to make exactly 10 knots on this course. What is the course to steer and what speed should I do through the water? So I create the, excuse me, the table. So I put in my made good, put in my values, my boat, I don't know what those values are, and then my current. So I'm going to go to this guy. You guys can see that. Okay, so we have our, well, let me get a bold color. Let's see if this works. Made good, boat, and current. Okay, so I make my little chart each time, and my made good, what I want to make good is 300 at 10 knots. So I'm gonna draw that line. I'm gonna get a better pencil. So I start from the center here and I find 300. So here's my 300 and I'm going to draw my line. Okay. Have my little plastic thing there. So mine's not exactly straight, but oh well. There we go. Okay, so I have 300, and then I want to get my distance. My speed was 10 knots. So in 1 hour, I would travel 10 nautical miles. So I can go from 0 to 10. And that's going to be right there on that circle. So I have a dot right there. So I have the center. I need 3 points to my triangle. I already have 2. I'm looking good. So I have, this is going to be my made good. My made good line. The next thing I don't have my boat. Those are question marks. But I do have a current that said it is pushing me to 200 at 2 knots. So I want to create my vector, and I know my made good and my current start from the center. So starting from the center, my current is going towards 200. I'll just draw a little line because I know it's going to be small. And it's 2 knots, meaning 2 nautical miles in 1 hour. So I'll go 2 nautical miles. That puts us right on the line again. So here is going to be that third point of my triangle. This is my current vector. So I have 3 points of my triangle. And if I connect the 2 points to create an actual triangle, that third leg is going to be my boat. So let's connect those dots. So this line is my boat line. Those are my missing values. So I had my made good line, my current line. If I connected those dots, I get what my boat is doing. What I should steer if I want to make this good and the current is pushing me. So in order to get a value on that, I have to parallel this triangle to the center so I can see it or get an actual measurement off of it. So I'm going to bring it to the center. And let's see if this makes sense. I always like to do this makes sense. So the current is pushing me to this, right? The current is coming at me, pushing me to 000. And I want to stay in the channel. Here's my channel. I want to make that good, or that's just the closest possible point to or the closest, point A to point B. I want to make this good. So if the current is pushing me, I need to steer into the current so that I can make this made good line, right? I want to steer into the current, and that will help me kind of crab along my my made good line. So I can see that, yes, I am going to be steering slightly to the right. So my course to steer is going to be, I've measured it here to be 311. And my boat speed, pretty close to my made good speed, but might be a little bit bigger because this one's kind of pushing us back a little bit, but let's measure it exactly. I have 10.6. So I need to go 10.6 knots by my boat, right? So that's putting it at RPMs for 10.6 or whatever it is. And steer a little bit to the right if I want to make good that 300 at 10 knots.
Bree, can I ask a quick question?
Yes.
Sorry, I was just looking away when I was writing something. When you just did with the dividers to get your boat speed, what were the 2 points that you picked up? I didn't see you do that.
Yep. So that is the 2 points that create the boat leg.
Okay, thank you.
Yep. That one right there. Okay.
So I have a silly question.
Yeah.
Do you ever just figure this out using math instead? These are just
No.
okay.
I am absolutely sure you could.
You just
Just
pull for
geometry.
vectors, so if you transfer them
Geometry. Yeah.
then add them, you're done.
Yes. Yes. It is just a mathematical triangle. You're making a vector. You could.
Okay.
I'm going to say most people don't, though.
Okay. At the end, when you finish this calculation, although you had your course made good, at the end you're going to wind up at your made good position, correct? You're going to drift. What I'm trying to say, from if you were heading on a course heading of 310, you're basically, when you finish though, when you reach your DR location, you should be at 300 course or true course.
No.
Yes, I think.
Yeah.
Right.
So,
So if you take your boat and you're on your made good course right now,
mm-hmm,
and you're heading on that course heading of 310 degrees,
mm-hmm.
and then, but by the time you reach your destination, your distance, you should have drifted down to 300, correct?
You're drifting along, that's your course made good, but that doesn't change your heading.
Right.
So here's, we were fishing over here and we're going to our lobster pot or something right over here. So we are going to be steering and the current is pushing us this way.
Correct.
So we are going to be steering the whole time a little bit to the right. As
Correct.
we're steering, we're still going to be pointed a little bit to the right when we get to our final destination. And then we hove to or make a course change, go wherever we're going to go. So that made good line, it always stays our made good line, but our boat, I can say like, I could even write this, on the chart, course made good, 300, course to steer, 311. And that's true. And then I'll have to convert it to compass. Okay, maybe that's 325 per standard compass or something.
Understand. Okay.
Why do we need to use the plotting sheet? Can't you do the exact same thing on a chart?
Yes, you can do it on a chart, you can do it on anything. And I'm gonna say in real life, you're probably gonna do this on the chart, right? We're using the plotting sheet right now to just exercise the concept of this triangle and how to find those missing values. It might not, this one's kind of straightforward, but it might get a little more confusing. So we're just exercising how to manipulate this triangle. And that's why we're using the plotting sheet.
And it's much easier on the plotting sheet.
It's much easier on the plotting sheet than trying to do it on the chart with everything else confusing us.
Okay.
Okay.
Hey, Bree, it's Brett. One question, just to make sure I understand. So this essentially would tell me, and again, forget compass versus true. I'm just going to use true because we did this example. So if I want to get to the point, I just would steer 311 and increase my speed to 10.6. That's what this whole exercise was for.
Correct.
Yeah. Okay, got it. Thank you.
Okay. Okay, so let's see how I did it on the PowerPoint here. We made our chart. We had our missing values of the boat. So my center, I can draw from the center. My course made good line, its distance was 10 miles. I draw my current line, its distance was 2 miles. Then I connect the 2 points and I create my boat's line. I can measure that at 10.6. And then I have to parallel it over to the middle so I can see what boat course it is. 311. So we were pretty close. Okay, let's do another one. Here we go. Our vessel, so our vessel is steering 270 at 8 knots. The current is 180 at 3 knots. What is the made good, right? What is the course and speed made good? So just by looking at this, I'm going to say it's pushing me to the south. My course is going to be somewhat south of west, right? My course made good if it is just pushing me. So maybe I'll do it on here and then I'll do it on the plotting sheet. I draw out my graph. I don't know what my made good are, so those are my questions. I have my boat. I know what my boat is doing, and I know what the current is. Maybe I got my current from a past one or something. I don't know. I know what the current is, and I know what the boat's doing. So from the center is the made good and the current, but I don't have made good, so I can't plot that from the center. But I do have current, and I have the beginning and the end point of the current. So I can, from the center, plot in 180 at 3 knots. So I use 3 nautical miles, plot my current line. And then from the end of that current line, I can plot my boat's line. So my boat line is 270 at 8 knots. So I use 8 nautical miles and I set it at 270. Then when I connect those 2 end dots, the 2 dots remaining of my triangle, I can see what my made good line will be. So it's a little bit south, or I measure the distance, which will give me speed. Okay, and my course made good. So let's do that on a plotting sheet. See if this will work a little bit. Trying to get better lighting here. So we have our made good, our boat, and our current, our 3 legs. Our made good, we don't know. I know the boat is doing 270 degrees at, was it 8 knots? Let me check. At 8 knots, and the current was 180 at 3 knots. Okay. Okay. Gosh, I am getting sloppy, you guys. I apologize. Okay, so my made good and my current start from the center. I don't know what my made good is, so we're going to start with current. So I'm going to plot my 180 at 8 knots. At 8 knots, I'm going to use that 12-mile scale. So I'm going to cross out those guys. So my 8 is going to be on one of those lines again. Great.
3, wouldn't it? Wouldn't it be 3 instead of 8?
That would be 3. You are right. Thank you. So I was like, wait a second. 3 knots, using our 3 for our current, puts us right here. So here is one end of my triangle. Here's the other end of my triangle. And now I need to write in my boat line, which is 270 at 8 knots. So I'm going to use 8 nautical miles. I'm going to go 270 I moved. Okay, so here is this is my current line. This is my boat line. I need to find the end of this line so I can connect my dots. I'm going 8 knots, so 8 nautical miles in 1 hour. Puts me right there. So now I need to connect my triangle, finish the triangle, and I can create what my made good line will be. So it's already from the center. I drew it all the way out so I can see it. I have about 249 degrees. And then I want to see what my speed made good will be. Can't do this one-handed. Is going to be 8.6, I'll say. So let's do the does this make sense check, right? My current is pushing me this way. If my boat is going like this, so from the center, if my boat is headed this way and the current is pushing me, I'm going to follow along that made good line. So that made good line is what I'm following. My boat is pointing 270. This one, because current is going straight down, a little bit harder to tell on the speed. The speeds are pretty close, but I think we're gonna have an example here where the speed is very obvious. So let's do one of those.
Hang on, can I ask a question? Two questions. First of all, why wouldn't we have a bunch of these radar transfer plotting sheets in the packet that just got sent to us? And can I get it from, do I just go to the OCC and get these things? Because it's really confusing trying to figure out my one copy of this maneuvering board that I have in front of me and trying to replicate what you're doing.
Yes, so when I'm in class, I just hand them out, and
Where
I've
do I
told
get-
them that we need this and they want to sell them for like 10 cents. And I'm like, why are we even selling them for 10 cents? Which I don't really understand.
Bree, I think you posted it on your Google website. So that's what I just did. I printed some while you were doing the job.
Yes, so
Yeah.
I also
Okay,
have
thank
that PDF available. So
Okay.
you could print some out right now on printer paper. They're a little bit smaller. If you could see, a printer paper is going to be a little bit smaller.
Yeah, no, that's fine. That's cool. Okay, so
But
that's what I'll
it's-
do. And then my second question is just, and it's been a while in geometry, but a squared plus b squared equals c squared. And I just kind of back of the envelope that math to get to the 8.54 distance.
So yes, that one's going to work because a squared, b squared, c squared is on a, is that on a right triangle?
Yeah.
Yeah, so that's
Let's
in,
work out in that situation.
you could look at it like it's vectors. So if you were to add the vectors, you're going to wind up getting the length. If you multiply the vectors, you get the angle. And you're absolutely correct. The if you do it mathematically, you're going to get 8.54.
Yeah.
And the angle difference in degrees is going to be 250.44.
Okay.
So yes, it is 100% possible to do this by math. Most of the time you already have what your boat is doing, or you already have your made good plotted on the chart. So maybe it's just a more visual way of doing it. Everybody's brains work differently. So if you're more of a mathematical person, do it that way. That's totally fine. I guess I've just found that this way works for just practicing this concept will help when we go to the chart next week.
Yeah, no, another thing in fairness to that chart is that it really helps when you got the arrows with the current. So you know if you did the math wrong or carried something wrong, it'll be pretty obvious.
Yes,
So
that we
it's
always
not-
do that common sense check.
Yeah.
And it's
Okay.
more of a visual.
Okay, thanks.
Okay.
How do we know what the current is?
How do we know what it is? We've compared it to our set and drift, where we've compared our DR and our actual position in the past and then predicted forward, or we've gotten it from our apps or our nav pups. So we're going to come to one where we have what the boat's doing and we have what's made good, and then we are then finding out what the current is. So I feel
And
like
you can safely estimate the current based on your experience over the previous hour?
yes.
Okay.
Okay. Let me go back. Okay. Jeez Louise. So this is the one we just did. Okay, now what happens if our triangle is not a triangle, it's a line? So that means we have a exact head-on current, following current, or no current. So we're going to use these same concepts of, well, let's look at one first. Here's our head-on current. So if what is made good, well, I guess I'm going to go with the boat for head-on. So my boat is doing some sort of speed and the current is coming directly at me. My speed is going to be a lot slower. So the current isn't pushing me from one side to the other. It's just coming directly at me, head on. my made good line is going to be a lot smaller than what my boat is putting out, right? Because the current is going to be pushing me, making me go slower. Now that's opposite when you have a following current, when you have that current pushing you from behind, making you go faster. Then you have your current, and then you have whatever your boat's doing. Your made good line is a lot bigger. So it's the same direction as your boat and your current, but it's a lot bigger, that vector, because the current is pushing you. Your made good is faster. If there is no current, then your made good and your boat would have the same vector. So I guess I would say sometimes you do have this head-on current or following current, especially if you're in, a narrow channel or something where you have this following current, a river, something like that. But other times that current is going to be a little bit off one way or the other. So we can help us with this common sense check of, does my speed make sense? Does this direction make sense? Where is that current pushing us, and how is it affecting what my made good vector is doing versus what my boat vector is doing? Is this kind of making sense with you guys? I don't know. I'm trying to visualize this concept here. Okay. Okay, before we leave our triangle, any big questions on our triangle? When you're going to get to, all of our homework assignments are practicing the vector triangle. So I promise we'll do it together. Okay. Quickly, going back to a little bit vocab. We have ocean currents versus our tidal currents. So our tidal currents are what happens near the coast, and our current, or that tide and that current are very closely related, right? As the current pushes water in, our tides will increase. As the current pushes water out, our tides will decrease. So they like to call them tidal currents. Then we have ocean currents. So ocean currents are these general currents that maybe not follow exactly, but they are very, very predictable. I don't know, they're very predictable. So does anyone, well, I guess we have the thing here. I would say the most popular current a lot of people know is the Gulf Stream, right? Has anyone sailed in the Gulf Stream on the East Coast? A lot of times you can see it. You can see the change of color from where the Gulf Stream is not to where the Gulf Stream is, and it will affect your boat and just kick you one way. So you want to predict if you are crossing the Gulf Stream, right? You want to cross it as quickly as possible. Or if you are traveling north, use it to your advantage. Use these coastal or use these ocean currents to your advantage. If you are going from, Newport to Hawaii, use that California current, also known as the Davidson current. Use it to help you. Use these typical ocean currents to help you out. Even if you don't remember the names of them, need a marker. Let me get a better marker. Okay, so this is a simple drawing of the Earth. We have land masses on either side. So this can be Pacific Ocean, Atlantic Ocean, whatever it is. On the, we'll say, it's the Pacific Ocean. Here's the USA. So that makes this South America, Australia, Asia. This is very simple drawing here. Does this marker work? Yeah, here we go. So on the California coast, so here's us in California, do we have warm water or cold water?
Cold.
Cold, right? Our ocean water is very cold as compared to other places around the earth. So our water is coming to us from the poles. So our water is coming from us to the poles and traveling south. And as it comes to the south, moves along like this, and it warms up. So in Indonesia, in Philippines here, we get this warm water moving north. So this is where we have the, humid climates. They have the typhoons. Our storms come over here and follow this curve of the earth. The water gets cold up at the poles and then comes back down the US side. Same with South America. It is cold. So our water comes from the poles and moves up, warms up across the equator, and then in Australia, South Pacific, we have this warm, humid, warm water in all of our South Pacific, Australian areas over here. It's very warm. And then the water cools and gives, Chile and Peru the cold water. So we can flip this to the Atlantic. Here's our USA, Europe, Africa, South America. Our East Coast, USA East Coast, Florida East Coast here has very, very warm water. And we get all these hurricanes coming from the warm water, right? And then the water gets cold. And in Europe, we have cold water. Our European beaches are going to be cold. And then it gets warm and it starts traveling. The East Coast of South America, Brazil, those are going to have our warm waters, and then our West Coast Africa is going to have our cold waters. So we can use this, whatever it is, Coriolis effect cycles of the ocean currents to our advantage. So if we are doing ocean crossings, we can use these warm, cold currents to our advantage. So that was my 5-minute lesson on ocean currents. There's a lot of details involved in that you can study if you want, but that's just my quick little lesson here. So ocean currents and tidal currents are different, but it's good to know all of them, I guess. Okay, other types of currents, wind-driven currents and rotary currents. We're not going to get into those, but we're combining all of these currents into what's actually happening to us in the moment, right? That's what we want. That's what we want to know. So we do the best we can, gathering as much information to predict where we are and see what's happening. We have a lot to cover, so I'm not going to get into wind-driven currents or rotary currents. Who was it? I think Michael is doing the U.S. Coast Guard exam. You might have some questions on rotary and wind-driven currents. They can be calculated with the current book and combination currents, but we're not going to dive into that. Okay. Now we are going to practice using our radar plotting sheets. I put here for our extra problems, this is wrong. For our extra problems in this week, they are lapware problems, so the answers are on the last page. For week 3, we're going to use the Murphy book, and the correct answer has a little anchor on it. There's not like the correct answers at the back. So I'll go over that again, but that's when we're looking at our extra problems. It's either on the back or it has a little anchor next to it. Okay. Let's take another little breather here. We'll take a 10-minute break, come back at 9:05, and we will do exercise assignment 1. The second page of assignment 1 is on your 1210 TR chart. So that's the Martha's Vineyard sound chart. So during the break, if you have that chart, bring it out, or print out some more of those radar transfer plotting sheets. We're going to do 5 examples of those and then go to the chart as well.
Okay.
All right. I'll be back in 10 minutes. All right. Did anyone have any questions they come up with when we were on break? All right, I'm going to try to do this with a marker, just so it's a little bit bolder for us. The lighting keeps getting worse and worse, but oh, maybe I can do that a little bit better. Okay. All right, so I'm gonna make sure we got our people back. Okay. So we're gonna try to get through as much as assignment 1 as possible. But I'm, let's see, pretty sure. Never mind. Okay. So can everyone see my radar plotting sheet? Okay.
Yes.
Okay, so I always like to start with my here. I'll put it to the side here. My little table. So my made good. I'll give it a little bit more space. My boat and my current. Okay. And then we always have our made good and our current from the center. So I'm going to kind of fill in these values. So for number 1, see if that doesn't want, let's see if this one works. Okay, getting colorful. So for number 1, it says we want to make good a course of 080 true. So that's, we want to make good 080 degrees true. You run a normal cruising speed, so that is me, my boat. My boat runs a normal cruising speed of 10 knots. The set is 140 degrees, and the drift is 4 knots. What course should I steer? So what is my boat's course to steer? And what is my speed made good? So you can see here on my 3 lines, I have 2 values for my current, but I'm missing 1 value for the made good and 1 value for the boat. So I need to figure out how to solve this puzzle. And we are going to start with what we know. So I'm going to kind of put this, I guess, off to the side a little bit. I'm trying to do this with a marker so we could see it well. Well, you guys can see it with a pencil. I like pencils better. So I know my made good starts from the center, and it is going to, I want to make good 0, 8, 0. So I'm going to draw in that line, 0, 8, 0. Sorry, there's something under here. Okay, so I know my main good line is going to be 0, 8, 0. The other thing that I know, and that starts from the center, is that my current is 140 at 4 knots. So I'm going to plot my 140. Shorter line. So this is my current line, and this is my made good line. And I do have an end to this current line, right? I am going at 4 knots. So see, my other one is 10, so I'm going to use the 12-mile scale. Cross this one out, cross. So I'm going to use 4 knots on my 12-mile scale. And that gets us to that bold line here. So here's the end of us, and here's the end, a point of our triangle. So now I need to figure out the rest. I know that I need to connect this triangle, but I don't know where to connect it, right? I don't know what my course to steer is. I don't know what my speed made good is either. What I do know is that my boat speed, I know I can make normal cruising speed for me is 10 knots. So I'm going to find 10 knots on my dividers. So I know the length of my boat. So my boat line goes somewhere from my current line, right? My boat line does not start from the center. It goes somewhere from my current line, but I don't know where. What I do know is that it is 10, that I'm going 10 knots, 10 nautical miles. So what I do is create a the length of my vector. I don't know where my vector is going, but I know that the length of this vector from the current line is going to be 10 knots. So I've created, you don't have to do an arc like this. You can have dividers. I'm just trying to explain it like this. Because you've already drawn your made good line, you can just measure where 10 miles is from your current line that hits their made good line. So this would be our final point of the triangle. We can connect those two. So we knew that this was 10 nautical miles. That's what we knew. So that means we can create this dot, because we knew that this line, but it goes on for infinity, right? We don't know where the final dot is on this line, if you will. So, so now we have a final triangle. Now we have 3 points to our triangle, and we could measure the distance of our made good, which will equal our speed, and we can measure the direction of our boat. This one here is our boat, of our boat line, to see what it is. And then we'll do our does this make sense check. Okay, so if I want to make good 080 and my current is pushing me this way, it's kind of pushing me toward, or kind of a following current. So I would say my made good speed is probably going to be bigger than my boat speed. My boat speed is going to be smaller. So if my boat speed is 10, I would say the current's pushing me a little bit, that my made good speed is going to be a little bit more than 10. Also, if I want to make good this and the current is pushing me, I'm going to have to steer into the current. So getting a course of 060 to steer makes sense, right? So I'm going to be steering this to make good that line. That is what my boat is telling me I'm going to do. So I'm still following my made good line. I've just altered my course a little bit because I have this current pushing us. So fill in my values, right? I can do it like this. I'll do it a little differently on the next one. Sorry, it's unorganized. So my boat to steer, this would be my course to steer, is going to be 060 degrees true. And then I have to measure what my speed made good is. I'm thinking that it's going to be a little bit faster than the 10, but let's measure. Oh, that's why I had it like this, so you can see. So I have, what do I have? 11.4.
Should be 12.49.
What was it?
12.49. Should be.
I got 11.3.
11.3, 11.4. It shouldn't be 12. Is that from calculating?
Yeah.
I got 11.5.
Yeah, 11.4.
Why would it be a whole degree off with calculating?
It can't be more than 12 on the graph.
We'll try another one. Let's try another one.
Oh, I know.
Another one with your calculating way. Let me see this one. 240.
Yeah, I mixed up the vectors. I thought that there were two complete vectors, and they were one vector didn't have one value. Got it.
Yes. Yes. So our two missing values were on different vectors.
Yeah, that's my fault.
Gotcha. Okay. So this example, we can see that even though our missing values were on different vectors, we can still solve the puzzle, if you will. So, yeah. Any questions with number 1? Let's
So
do
Bree,
number
the
two.
answer. So Bree, the answer to B would be
11.4.
so 11.4 nautical miles.
Correct. Or so we would travel 11.4 nautical miles. It says speed, so that should be knots. I see that it says.
No, because the question is after 1 hour, how far you have traveled.
Right.
So is that,
Yeah.
that numerically is equal to the knots?
Yeah, because we're set on the hour.
Yeah.
Okay. I'm gonna do this one on here. Maybe it'll make more sense. We are reaching, I think that's a sailing term. We're reaching at 6 knots and we want to make good 240. So again, our boat is doing 6 knots, but we want to make good 240. So those are different vectors. So it's kind of those like word problems again, right? We're really reading these word problems. Our boat is doing 6 knots. We want to make good 240, and we have a set and drift to be 280 at 15 knots. So I'm going to be doing, I'll do it up here. So we have made good. Boat. So my made good is 240. And I know that my boat is doing 6 knots. My current is 280 at 1.5 knots. I'm still going to use the 12-mile scale. Someone could try it on the 6-mile and tell us how it works out. You might go a little bit over, but it's still a measurable distance. Anyways, I'm going to use the 12-mile. So I'm going to start with what I know. My made good is 240. Sorry, my made good line is 240. My current is 280 at 1.5. So here's made a big line there. 280, this is going to be my made good. This is going to be my current line. My current line ends at 1.5. So 1.5 gives us a dot right there, and we have the center. So now I need to figure out on my boat line, where does it hit my made good line? Where does it go? What I do know is that my boat's speed is 6 knots. So in 1 hour, I'm going to go 6 nautical miles. So from my current, I'm going to go 6 nautical miles. So that creates a boat line of 6 nautical miles. So now I have my 3 points of the triangle. I need to connect those. Scoot it over. There we go. So if my current is pushing this way, right? Here's my current, and my made good is this. I need to steer into the current. So it makes sense that I need to come to the left here. So I had to parallel this line back to the center. I did a little dotted line here. So I got my made good, or my boats course, to be approximately 230, 231, something like that. And then I want to know what my main good speed will be. So it's a little bit of a following current. So I would say my speed is going to be more than 6 knots. But let's
7.05. Or actually 7.06.
7.1, 7.06, yeah. $7.1, 7, something like that. How you guys doing on this?
How often do you have information that's only broken up like that between the vectors? As you'll know, the angle of made good and the speed of the boat.
I guess it depends on what you're, I want to say recreationally, you kind of have a solid number of what your boat's doing, and you don't really care as much as your speed made good. That's not really a priority for a lot of recreational boaters. So your known would be your boat speed, and then you'd want to know what your made good would be. So it would be split up. I would say commercially, a lot of times you're looking for an ETA. I know I'm meeting the pilot at 8, or I need to make arrival at this time. So I want to plan exactly what my speed will be, and I can adjust my speed, minutely. I don't think that's very practical in the recreational world. I don't see you adjusting your speed as much as commercial vessels do. So yeah, I think it's split up a lot.
Okay. And how far out do you go? As in, this is one vector addition. Do you ever calculate it out for more than one turn?
You can say you're going from, we're going to create a make-believe problem here. I don't know, you're going from this buoy here to this harbor here or something. You can calculate, the current over here in this area is going to be, going in this direction. When I get to the center of the channel, it might be more pushing like this. And then when I get over to this side, it might be pushing like this. So if I want to go, from point A to point B, I can combine all of these vectors to say, to make it there, my average vector is going to be pushing me this way. So I'll just steer, finish my triangle, and steer that to average the vectors out. So yes, you can combine the vectors, but I'm going to say most of the time there's little adjustments along the way, that you're not going to get this big change crossing a channel or something. But you will get different, currents affecting you right on the coast of Newport versus when you're approaching Catalina or something. But I would kind of break it up in, okay, here's my NWP buoy. Here's Avalon. I would say, okay, from, waypoint here to waypoint 2, this is my current that's going to be affected. Waypoint 3 or waypoint 2 to waypoint 3, I might have another current. As I make my approach to Avalon, I might have a different current, and kind of adjust my currents and break it up per leg and not try to like average it out right here so that I'm just steering something that I'm compensating for in Avalon, because it might change. I always want to be as close to your, original track line as possible. So if you're steering over here to compensate for a current that's over here, yes, eventually it's going to push you back, but you might steer for this current. You're steering for this current here, adjusting your speed, and then steering for this current when you're closer there. So you'll be changing your course along the way. And I think that's more manageable to be navigating and changing course instead of just setting it at one position and then forgetting it and hoping you arrive at your final destination. Hopefully you're plotting your position more and more along the way so that you can adjust your speed and plot the actual set and drift that's happening and stuff along the way. I don't know if that kind of answered your question.
Yeah, that makes sense. I was more asking about, you could just add more vectors to it as you're going to handle the different changes in current, and you'll wind up with the same result as if you had done it in each step.
Yeah.
Okay.
Bree, I assume in the real practice, as long as you are close enough to your destination, you have a visual, you don't really need to do this, right? You just, sitting, aiming to your destiny and making you change your steering directions as you need it, right?
Yes. You can though, let's see, let's draw here. You see Avalon, that's your final destination. If the current's really pushing you, you can just like keep adjusting. I don't know if this makes sense. You just keep steering towards Avalon, but the current keeps pushing you, and you could end up, somewhere in a shallower area that you might not want to be. So that over the ground is really important in compared to what you're steering.
Okay, very good.
And it's very okay, I'm not going to say it's very easy, but when you're looking at a GPS unit with electronic navigation, you have a lot of times you'll have a bearing and a course made good. And you want those two numbers to be the same, meaning the bearing to your final destination or your waypoint and your course made good is the same, even if your heading is not. So if I'm headed this way, my heading is different, but my bearing to my final destination, my waypoint, and my course made good would be the same. When you see these a little bit different, let's call it, what is this, 230, 230, oops, we'll just do 233, let's say that the bearing is 230, but my course made good is 233, meaning a little bit more. So I'm starting to do this. I'm starting to drift off my made good. If I adjust my heading by 3 degrees, come 3 degrees to the right, that gets my bearing and my course made good closer together.
Yeah, understood. Very good. Yeah, very good point.
Okay. Well, guys, we have run out of time. I meant to get more of our homework assignment done, but it is 9:30. And I will record this and put a homework tutorial up, as well as the oh gosh, stop sharing, there it is. As well as the extra questions. So please wait for that. It'll be up by this weekend, I would say. Over the week.
Real quick, what's the course, the Google Classroom number we should use?
Let me copy it and put it in the notes.
You, yeah.
Copy. There we go. It's letters.
Thank you.
All right. Well, yep. Homework for this week will be assignment 1. The first 5 are just practicing those triangles on the maneuvering boards or plotting sheets. And then the second half is on the training chart. And then the lapware questions, those extra questions, are going to be all on plotting sheets. So that's just extra practice. If you guys got it, you guys got it. We're just going to be building from here next week, so it's good to keep practicing this.
Okay.
Yeah, that's all I got for you guys.
Thank you, Captain.
Thank
Have
you.
a good
night.
weekend.
Thanks,
night.
Bree.
Thank you, Bree.